Alright, so let's quickly look at our grade 11 electrical circuit. So now remember that definition of Ohm's law says that it is the what? It is the potential difference across a conductor. It is directly proportional to the current in the conductor at a constant temperature. So basically Ohm's law tells us about the relationship between the potential difference and the current, meaning that when you increase the current, you are also increasing the voltage. But if you are increasing the current, it means that now it will be decreasing the resistance, meaning that if you increase the current, meaning that when you're increasing the current, means that you are also increasing the voltage of the circuit as well as decreasing the resistance of the circuit. So now this is how we're gonna use Ohm's law formula. For instance, if we are looking for the voltage, basically mean that you're gonna cover voltage, and you can see that we have I, that is multiplied by the resistance. So you're gonna I multiplied by the resistance. Then if you're looking for the resistance, you can see that your current, it will be equal voltage. This is division. This line represents division. So it contribute voltage divided by resistance. And you get the resistance as well. You can say voltage divided by the current. Okay, and then also remember that in series connection, your current is going to be the same throughout each resistor, and also remember that the voltage divides itself. And also remember that how to get the resistance in series, whereby you're going to say R1 is equals to RS equals to R1 plus R2 plus R3. And then also when are connected in series, it means now your current start to do what? Start to divide itself, meaning that current, let's say more current will go to a branch that has less resistance. And then from voltage, now the voltage in parallel connection is the same throughout each branch. And now to calculate the RP, if you are given the two resistors that are connected in series, that are connected in parallel, so basically you can say R1 multiplied by the R2, that is equals to R1 plus R2, meaning that you're gonna say your RP is equals to the product, because when you multiply into it, you get the product, and then when you add, you get the sum. So basically, if you have two resistors that are connected in series, in parallel, you're gonna say RP is equals to product divided by the sum. Or we can also use this one, where it's equals to 1 over RP. At the end, you have 1 over RP, that is equals to let's say you got 1 over 4, meaning that you're gonna tip and times, meaning that you're gonna say RP now equals to 4 over 1, for which is 4, meaning that you will take this 4, you're gonna put it that side, and then 1 downstairs, right? That's how you're gonna do that. Or we can even say 1 over 4, like 1, if we get 1 over RP, that is equals to 1 over 4, and then we say to the power of negative 1, all to the power of negative 1. Then you get your RP. Now let's look at this activity 1 that says that now here we are given the diagram below that say that the armature and the battery has negligible internal resistance, okay, as indicated in the diagram below. So the potential difference across a battery, it is 12 voltage, right? We have 12 voltage, and you can see that now our resistors is consisted of what? A combination of parallel connections as well as series connection, because you can see here, let me make it like this. Here you can see it's connected in what? In parallel connection. And I say that the reading on here, on this branch, it will be the same reading on this branch. And then remember, in series, the voltage is going to divide itself, meaning that you're going to this 12 amount is going to be divided so that it can be read here at 2 resistance, and you can see this 2 ohm is connected in series. Now they say that you must, in 1.1, you must calculate the effective resistance of the circuit. Now if they say effective resistance of the circuit, it means that you must go and look for the total resistance. Meaning that our RP, our RT is going to consist of RP plus RS, because we have combination of parallel and series connection. Now, because here in RP, I can see that I have what? 2 resistors that are connected in what? In parallel connection, meaning that I will say the product of them, sum of them, divided by the sum of them, for which I will get what? 6 ohms. Then your resistance in series, you can see that is only one, which is 2 ohms. Now, meaning that your RP from this, you're gonna say, let me write it here, your R total consists of R parallel plus R at series. Your R parallel is 6 plus your R resistance is 2, for which you will get 8 ohms. So that is your total resistance of the circuit. Now in 1.2, it says that you must go and look for the voltmeter reading. Go and look for the voltmeter reading here at the voltmeter. Then you can see that here these 2 resistance is connected in series. So remember that in series, it means that in series connection, remember that your current is the same throughout resistance, meaning that the current that will flow here, it is the same amount that is going to flow here, but in parallel connection, that thing is going to be split apart, your current. Now, and also have to remember that in series, we say that the voltage is going to do what? Let me say the V is going to divide itself, meaning that this 12 amount is not going to go here, it's going to be divided. So now we're looking for that voltage that is going to be divided. So now, as you can analyze here, you can see that you have the total resistance of the circuit and we have the total voltage of the circuit, meaning that you can get the total current of the circuit, for which you're going to pass here and here, right? Meaning that I can really say R, that is equals to V over current, for which I'm looking for the current, meaning that I will make the current the subject of the formula, whereby it equals to be I, that is equals to V over R. Then your voltage, which is 12, then your resistance, this resistance, it will be what? The total one, which is what? 8. Then your current is 1,5 amps. Now we have the total current that will pass through the 2 ohm resistor, meaning that now to look for the voltage, basically here you're going to make the voltage the subject of the formula, which is going to be the voltage that is equals to resistance, current multiplied by the resistance, for which your current is 1,5 multiplied by the resistance at that resistor, which is 2, then for which 1,5 multiplied by 2 you get 3 voltage. Now when you look at 1.3, it says that the energy produced in 1 minute in the 2 ohms resistors. So it means that you were looking for the energy transferred. So now remember the equation for the energy transferred. It will be like our energy, W, that is equals to voltmeter multiplied by the current multiplied by the change in time. Or we can go from the one that says V squared all over R multiplied by the change in time. So basically this one, it is the same as when we say Vs squared all over R multiplied by the change in time, like this, same thing. Then now remember here we are given 1 minute, that means that we have to convert our minutes into second, which is 1 minute is equal to 60 seconds. So basically we have what? 60 seconds. So therefore, meaning that I can normally use this one, because hence that I have what? You have the voltage, the current flowing through that, and also the time. Or we can use Vs squared multiplied by changing time all over R. So we choose the first one, which is Vi multiplied by the changing time, for which your voltage, it will be 3, multiplied by your current at 2, which is 1,5, same throughout the circuit. Then your time is, it will be at what? 60 seconds. And then when you get the product of that, you get 270 joules. So that is the energy that is transferred in 1 minute in that 2 ohm resistor. Then let's quickly look at this one that says that now here we are can see that still is the same combination of parallel and series connection. Then we are given that the battery has the EMF of 12 voltage and a significant internal what resistance. Okay, and then now they say that the reading on armature, it is what? 3 amps. So we have 3 amps here that you want to read there, which is 3. This 3 amps is the same here as 3 amps, but this 3 going to what? Divide itself here, because we have what? Parallel what? Connection. So the first question is 2.1. It says that you must go and calculate the reading on voltmeter V1. Where is V1? Here it is. So when you look at V1, you can see that the V1 is going to read the whole thing, meaning that you're going to read the whole thing, the combination of the series and the combination of the parallel connection. So 2.1, meaning that you have to go get the total resistance of the circuit, meaning that you're gonna say your RP. You can see that we have 2 of them, which is 6 multiplied by 3 all over 6 plus 3, for which you get 2 ohms. Then your RS is what? 1, meaning that your total resistance of the circuit, it will be consisted of 2 plus 1, for which is 3 what? Ohms. That is your total what? Resistance. And we have the total voltage and the total current, sorry, of that, for which our voltage, it will be consisted of V all over I over R. I times R. Voltage is equals to I times R, for which your current, we say that is 3 multiplied by the total resistance, which is 3 as well, and then 3 multiplied by 3, we get 9 voltage, right? Because we have an internal resistance here, right? And then now this, it will be your external resistance of the circuit, the external voltage. So the external, the external what? Voltage. And then now in 2.2, they say that you must go and do what? The voltmeter reading at V2. But at voltmeter V2, we know that the current that flow through that, basically this V2 now, it reads the combination of parallel connection only, for which we know the total current that will form here, it will be 3, and then we have the total resistance, which is what? In a parallel connection, 2, meaning that now our voltage at V2, it will consist of the resistance, the current multiplied by the resistance in parallel connection, for which your current is 3 multiplied by the total current in parallel connection as what? 2 ohms. Then 3 times 2, you get 6 voltage. Okay, and then now in 2.3, they say that we must go and calculate the energy transferred in 3 resistor where it is. This is your 3 resistors in 2 minutes. In 2 minutes. So we know that 1 minute consists of 60 seconds. So basically 2 minutes into 60 seconds into second, it will be what? 120 seconds. Then from there we know that the energy transferred is W. That is equals to, here we can normally use okay, let's previously we used that one is equals to VI is equals to I multiplied by changing time, and here we're going to use Vs squared multiplied by the time, changing time, that is equals to resistance. And then your voltage there, you can see that we found it there. How much is it? 6 voltage multiplied by 120 divided by the resistance, which is 3. Then now here you got how much? You got 1440 joules. So remember, energy transferred, heat transferred, you're going to measure it in what? In joules.